This week, we start work on the demand estimation. We are going to use certain economic and statistical techniques to explain the demand. Because it's important for the manager to use whatever tools and data available to explain the demand for their products. The procedure commonly used by economists to estimate consumer demand is regression analysis. Regression analysis is a statistical technique for estimating the relationship among the variables. The focus is on the relationship between a dependent variable and one or more independent variables. More specifically, regression analysis helps one understand how the typical value of the dependent variable changes when any one of the independent variables is varied, where the other independent variables are held fixed. We usually develop an equation to express the linear relationship between the dependent variables and the independent variables. The general form of multiple linear equation is shown in this formula: y equal to a plus b1x1 plus b2x2 plus b3x3 until plus bnxn, where y is a dependent variable and xn from x1 to xn are independent variables. Y is the estimated value of y variable, it's a dependent variable, for selected x values. In this chapter, y is the estimated demand, and x will be the factors which affect the demand, such as the price, taste, your income, consumer's income, and the price of related products, and so on. A is a constant value or intercept, the value of y when all x are 0. So A is the value of y when all x are 0. B1, B2, Bn is the amount by which y changes when that particular xn increases by 1 unit. For example, By is the amount by which y changes when x1 increases by 1 unit, with the values of all other independent variables x2, x3, xn are held constant. The subscript n is 1, 2, 3. The subscript n is simply a label that helps to identify each independent variable. The first independent variable, the second independent variable, is not used in any calculations. We usually call B1, B2, Bn the coefficients of that particular x. Now let's start the process of demand estimation. Step 1. We specify the regression equation and obtaining the data. In order for you to understand better, we are using example through the whole chapter. Let's assume we wanted to estimate the demand for pizza by college students in the United States. Express it in equation. It will be something like this. Y is the quantity of pizza demanded. What are the x's? Which means what variables would most likely to affect their college students' demand for pizza? We could start to answer this question by using price and all other related non-price determinants listed in the previous chapters. Ideally, all variables that are believed to have an impact on demand should be included in this regression analysis equation. In reality, the variables used in regression analysis are based on the availability of the data. In this case, to determine the demand for pizza, we collect the information for y and x1, x2, x3, and x4. So y equal to a plus b1 x1 plus b2 x2 plus b3 x3 and b4 and x4. Y is the quantity of pizza demanded. The unit is average number of slices per capita per month. A is a constant value, or we say y-intercept. X1 is average price of a slice of pizza, the unit in cents. X2 is the annual tuition in thousands of dollars. Because it's very difficult to find out the average income of the students or their families who attend a particular college, so tuition was used as a proxy variable. X3, average price of the 12 ounces can of the soft drinks in cents. X4, the location of the campus. Why we include the location in this analysis? Because we use it to tell if there are a lot of substitutes available. For example, compare Plymouth State University, which is in a small town up north New Hampshire, to any college which is in Boston City. Students in PSU have much less choices of restaurants than the students who live in Boston, the urban area. The unit of the measurement for the location variable is quite different from others because the data for locations are not quantitative data, means it has nothing to do with numbers, so we have to give some codes to it. We give it 1 if located in urban area, in concentrated urban area. We give it a value of 0 if otherwise. And b1, b2, b3, b4 are coefficients of the x variables measuring the impact of the variables on the demand for pizza. So now equation can be written as y equal to a plus b1 x1 plus b2 x2 plus b3 x3 and b4 x4. Let's assume we conducted a survey of 30 randomly selected colleges campuses in the United States and collected those data during a particular month. For example, for the college 1 in the list, the estimated quantity demanded for pizza is 10 slices per capita per month. The average price of a slice of pizza is 100 cents. The annual tuition of that college is 14,000. The average price of a 12 ounces can of soft drink is 100 cents. And this school is in urban area. After we specified the regression equation and obtained the data, we start the step 2. Run the data analysis in Excel. In Excel, on the top bar, click Data on the top, then click the Data Analysis. If you cannot find a data analysis in your Excel, please check the Add in the Data Analysis toolpack to your Excel I posted on Moodle. Then select Regression here. Click OK. In the input Y range, select the column handed by Y. Then in the input X range, select all the data for independent variables, including the labels. That is from the C1 here, C1 to the F31. Then click Labels, then click the New Worksheet, then click OK. Then you will get a regression summary output based on the data collected. On the bottom here, you can find the coefficients for intercept, that's 26.66 for intercept. Coefficient for x1 is minus 0.08775. The coefficient for the x2 is 0.1382. Coefficient minus 0.07589 for x3. Coefficient 0.054442 for x4. Now we can plug these values into the equation we developed, which gives us y equal to 26.67. That's the value we got for the intercept, minus 0.088 x1 plus 0.138 x2 minus 0.076 x3 minus 0.544 x4. So those coefficients are actually the values for A, for B1, for B2, for B3, and for B4. Now we can move to the next step. Step 3. Check signs and magnitudes. So we need to check the signs and magnitudes of the equation. The signs show that what direction of impact changes in the independent variables are expected to have on the demand for the products. The negative sign indicates an inverse relationship between the independent variable and the dependent variable quantity demanded for the product. The positive sign indicates an indirect relationship between the independent variable and the dependent variable quantity demanded for the product. Magnitudes tell us how much the demand for the product will change relative to a unit change in each of the independent variables. So back to our equation, you find out B1 is minus 0.087. It's negative. That means the price of the pizza, x1, is an inverse determinant of the quantity of pizza demanded. So a dollar increase will result in a decrease in quantity of demanded for pizza of 8.8 slices. B2 is 0.138. It's positive. So means higher tuition costs are associated with a greater demand for pizza and vice versa. Thus, pizza appears to be a normal product. A tuition increase of 1 unit will result in increase in quantity demand for pizza of 0.138. B3 is minus 0.076. It's negative, indicates inverse relationship between the price of soft drink and quantity demanded for pizza. This indicates that a soft drink is a complementary goods. The price of the soft drink increases by $1 will decrease the demanded for pizza by 7.66 slices. Before is minus before is minus 0.544. It's negative. Tells us that those students attend the college in urban area will buy about half a slice of pizza per month less than their counterparts in suburbs or rural areas. After check the signs and the magnitudes of the equation. Next step, we need to compute the elasticity coefficient. Why? In order to tell whether the magnitudes of the coefficient are high or low, elasticity of demand can be used to gauge the relative impact that independent variables have on the quantity demanded. Here we are using the point elasticity. Why is not arc elasticity? Because we are not checking or measuring the elasticity over part of the demand curve. We try to find out the elasticity of a certain point. Remember in the last chapter, the formula for the point elasticity of a linear equation, for the linear equation is like this. So elasticity equal to change in the quantity divided by change in that variable, independent variable, times independent variable over the quantity. So where Q is quantity demanded, here in this case, and X is any variable that affects Q. Delta Q means a change in the Q, and delta X means a change in X. So delta Q divided by delta X is actually the coefficient of the each variable X, such as B1, B2, B3. Assuming the following values for independent variables: price of pizza equal to 100 cents, annual college tuition x2 equal to the 14,000, price of the soft drink is 110 cents, location on campus is urban area. Why we assume those values? Because we try to find out a specific X and a specific Q. And this part, as we said, this part equal to the coefficient of each variable, so it's given information. We find out that from our Excel output. What we need now is the specific value for X and Q. That's why we assume those values. In the exam or exercise homework, this part also will be given information to you. Then inserting these values into the estimated equation. So y equal to 26.67 minus 0.088, that's a coefficient for x1, times 100, because now we see the x1 is 100, plus 0.138 times 14, the given information 14, minus 0.076 times 110 cents, minus 0.544 times 1. So we get, for given information, we get the quantity demanded for demand is 10.898, or we say 11. To compute the point elasticity for each variable, assuming the preceding values, we simply plug in the numbers into the point elasticity formula. So now we can calculate the elasticity for our variables. The first one, for x1 is the price of the pizza. Price elasticity, so equal to the change in quantity divided by change in the x1, which is the coefficient for x1, 0.088. So price elasticity is minus 0.088 times 100 divided by 10.898. This 100 is a given information. We assume the price is 100 cents, and this 10.898 is what we just calculated the value for the quantity. So solve this for the price elasticity, it gives us minus 0.807. Once we get this elasticity, we have to explain it. So demand for pizza is somewhat price inelastic because the absolute value of minus 0.807 is less than 1. Means price elasticity demand for pizza by college students is price inelastic. Based on what we learned from the previous chapter, when the demand is price inelastic, we should know that if we want to increase the total revenue, we better raise the price instead of cutting the price. Tuition elasticity is the coefficient for the tuition for the x2 is 0.138 times the value we assumed for the tuition is 14 divided by 10.898, the value we calculated for the quantity. Then solve this for tuition elasticity, we get 0.177. This means pizza is normal goods. because it's positive, but the elasticity is less than 1. It's very, very low, indicating that tuition does not appear to have that great impact on the demand for pizza. So the next one is cross elasticity. So the coefficient for the x3 times the value we assumed for the price of the soft drink, the 110, divided by the estimated value 10.898 equal to 0.767. So some degree of elasticity between the soft drink and the pizza. There is one more, right? It's about the location. I did not put it in the slides, but I can explain now here to you. So the elasticity of the location is 0.544 times 1 divided by 10.898 equal to minus 0.049. So it's very inelastic because it's a very, very small number. It's 0.049. The absolute value is 0.49. Means the location does not matter. So far, we specified the regression equation, and we found out the relationship between the quantity demanded for pizza and all the independent variables. We found out if they are negatively related or they are positively related. We also, through the elasticity, find out if the quantity demanded of pizza responded to the change in the price of the pizza, responded to the change in the tuitions, respond to the change in the related products. So those regression results are based on the 30 colleges across the country. How confident are we that these results are truly representative of the population of the college students? In statistics, population means the entire set of the individual or object of interest. So here, in this case, population means all the college students in the United States. We use a statistical method to evaluate individual regression coefficients to see if that coefficient matter for the whole population or just matter for the samples. The basic test of statistical significance of each estimated regression coefficient is called t-test. Another important statistical indicator is the coefficient of determination. It's written as the R-square. R-square shows the percentage of the variation in the dependent variable accounted for by variation in the all independent variables. You can find out the value for R-square in the summary output in the Excel. T-test is conducted by comparing the t-value for each estimated coefficient to the value of 2. So how to find a t-value for each estimated coefficient? Back to the summary output we just got from our Excel data analysis running. Here you go. Here is a t-stat. So the t-value for x1 is minus 4.858. The t-value for x2 is 1.595. T-value for x3 is minus 3.947. And t-value is minus 0.615 for x4. Once we have the t-values for each independent variable, we compare the absolute value of the t-value to the 2. If the absolute value of the t is greater than 2, then we can conclude that the estimated coefficient is significant for the whole population, not only just for the samples. For example, the absolute value for x1, the price of the pizza is 4.85. It's greater than 2. That means the coefficient minus 0.0877 is also true for the whole population for all the students of all the colleges in United States, not only just for those 30 colleges. This is very important because the elasticity we get, the equation we get, the everything we calculated based on the numbers here, the coefficients we get from those 30 colleges, and now we can use this for the whole population. Degree of freedom. Select the 0.05 level of significance. Usually, the degree of freedom, the level of significance is given information, which means that you can be 95% confident that the results obtained from the sample are representative of the population. Rule of 2. I already talked about this. Let's repeat. If the absolute value of t is greater than 2, then we can conclude that the estimated coefficient is significant at the 0.05 level. Means you are 95% sure and confident that the estimated coefficient is significant for the whole population. Okay, back to check our example. So the T1 we get is minus 4.858, T2 is 1.595, T3 is minus 3.94759, T4 is minus 0.615. So x1 and x3 are statistically significant because their absolute t-values are greater than 2. The other two variables, x2, the tuition, and x4, the locations, are not. We can be 95% confident that x1, price of pizza, and x3, price of the related product, soft drinks, truly have impact on demand for the whole population of the college students. B2 and B4 are non-zero. We get from our regression summary output simply because the fluke in the sample of the students that we took from the population. So means the coefficient we get for the B2 and B4 are only for those 30 colleges, cannot be used for the whole population. Any estimated coefficient of variable passes the t-test, we can be confident that the variable does have impact on demand. For our pizza case, the coefficient of determination r square. You can also find out the r square from the Excel output. It's here. So under regression statistics, r square is 0.71, which means that about 72% of the variation in the demand for pizza by college students can be accounted for by the variation in the price of pizza, the cost of tuition, and the price of soft drink, and the location of the colleges. After all of those analyses, now let's start our conclusion. We need to get into our conclusion, the implications of the regression analysis for management. In our pizza example, the result indicate that the price of pizza and the price of the complementary products, the soft drinks, are key factors influencing the demand for pizza. Their elasticity coefficients are both less than 1, and both variables coefficients pass the t-test. Means for those in pizza business, they can expect the price decreases to lead to a decrease in total revenue, other factors remaining constant. Therefore, they would probably not want to try lowering the price in an effort to increase the sales. This is based on what we learned about the relationship between the elasticity and total revenue. But they could try lowering the price of soft drinks with the anticipation that the lower price of the soft drink will attract people to buy the pizza because the soft drink and the pizza are complementary goods. We also learned that tuition and location do not have a statistically significant impact on pizza demand because they did not pass the t-test. Moreover, the magnitudes of their coefficients are relatively small. For managers of the national chains such as Pizza Hut or Domino's, this would indicate that they would not have to concern about the types of college. If that's private school with a very high tuition or public school with lower tuitions, or its location, urban or rural area, in deciding where to open pizza franchises. Because people's demand for pizza does not respond that much to the income change or where you're located. Okay, that's all for the demand estimations. For your homework, please follow the 5 steps and give very specific calculations and explanations for each step for each independent variables. If you have any questions, please send me email or let's make an appointment to meet online office hour.